Hello, my name is Mohammad Hanif. Thank you for joining this talk. Today I'll be presenting orchestrating inter-datacenter connectivity with MPLS VPN. This is a joint work that we have done alongside with Brocade and Huawei. So first of all, the agenda for this talk is I'll provide some overview, also motivation, why we are doing all of this work. Then, quickly moving on to providing you all the MPLS VPN building blocks. Next on, I'll be shifting to talk about some of the OpenStack operations workflow to talk about what is really involved in getting this one processed. Followed by providing you some real-world layer 2 data center interconnect use case about it, and also then move on to talk about some of the future work that we are doing in that area, and finishing it up with the summary and the key takeaways for this talk. So moving along, why inter-data center orchestration? So one of the things basically you have to see this thing is that cloud is not just one data center, right? Cloud is composed of multiple data centers, and that's entirely the motivation for this work. We view cloud as a pool of shared resources that are geographically distributed. They are not contained within one data center, and hence this is entirely the motivation. Also, tenant network spans multiple data center. And again, we would like tenant to be able to use the pool of shared resources that are scattered across multiple data centers that are geographically separated. So that's the motivation. Another thing is that today we have the technology provided to us through MPLS layer 2 VPNs and layer 3 VPNs that we can utilize in order to really bind and bring all of these things together, and this is we're going to utilize that in order to achieve our inter-data center connectivity. So what does MPLS provide us in order to achieve that? It actually provides us QoS guarantees. It provides us network resiliency. Another thing it also provides us is that seamless movement of workloads such as VMs across data centers, and also it allows you to have optimal placement of large flows. The data backup across inter-DC WAN. And I'll talk about this one, more in the future work as well. So again, this is just to depict how we view this work and how the OpenStack is going to help us bring all the data centers together. So essentially, the work really assumes that we are building, the cloud using multiple data centers. All these data centers are connected through MPLS backbone, and they are running BGP. So the assumption here is that there is a BGP connectivity between the border routers, the data center border routers, and also the idea here is that to really bring in all those physical networks, physical tenant networks that are logically separated to view as single logical network, and be able to really configure it, and also be able to have any types of sharing enabled across data centers. So moving along, in order to really present how all of this thing comes together, I just wanted to go over some of the key points. What are the building blocks that allow us to take us to the next level? Some of the building blocks we have here is that we define attachment circuits. So what is an attachment circuit? So attachment circuit is can be viewed as some of the logical interface. Okay, so this is a logical construct that is part of a access network. Another thing is that we define something called provider edge. So provider edge is can be viewed as the border of the data center. Again, the idea here is that your attachment circuits are part of your provider edge node, and that allows you a connectivity from your provider edge to your customer edge. So if you were to really visualize it, your attachment circuit part of the provider edge, and then on top of it you have another logical construct called tunnels. And tunnels allow you to really have this logical connectivity between one provider edge to another provider edge in another data center. So think about this one is that provider edge from one data center to another data center, connecting it through tunnel. In this case, our use case talks about MPLS tunnels. Another thing that we also talk about then is that the construct called MPLS VPN. So again, the idea here is that this MPLS VPN is a construct that enables connectivity at a network level. So tunnels allows you to carry out at a transport level, but the VPN allows you to create this kind of virtual private network. So having defined all these building blocks, we are going to move to the next level and then talk about what are the OpenStack operations workflow using these building blocks. Okay, so we are defining the Neutron API extensions. We have already made a blueprint. It's part of now and we have also built a POC that we have demonstrated in our demo, and we have to drive this one now to the next level by getting it reviewed and then eventually getting it approved through the process. So I guess once again, what is the workflow? So first we talk about the attachment circuits in the tenant network. So you define attachment circuits in a tenant network. It is treated as a logical interface, and in this use case, say in layer 2 networks, it can be represented as a set of VLANs. Next, you define MPLS LSP tunnels. This step is optional if you are doing dynamic tunnels using LDP, but if you are doing traffic engineering tunnels, you need to define this one and you need to configure it. Then we come down to the MPLS VPN. So MPLS VPN service puts everything together. It brings it in and it defines these LSP tunnels between provider edges, and then the provider edges have attachment circuits, and then you have the entire picture coming together. Lastly, we are talking about some of the other parts such as MAC withdrawal for faster convergence. In the case of VM movement or VM deletion, we detect that part and be able to really talk about the MAC withdrawal across the network. Some of the other things that I also want to mention here is that the definition of a provider edge part is that you don't really have to really define all the provider edges in the network, as I talked about from the perspective of BGP, that we are going to be utilizing the BGP's auto discovery method in order to get to that part and be able to really discover different provider edge within the VPN, as well as also advertise ourselves to all the other provider edges within the VPN. So here is again really going into the L2 data center interconnect use case. In this one, what I have really tried to explain is that within this one we have this data center core routers connecting through the MPLS network, and then we have leaf spine network depicting the customer edge networks, and then we have the servers carrying the VMs. The idea here basically is that you can actually use either the central OpenStack orchestrator, or you can have a distributed one. So our proposal does not limit you to just a central one, but it gives you a flexibility to have it either central one or the distributed one. Another key thing to note here is that again the idea is to have run BGP, do an auto discovery of all your peers, and then also be able to use perhaps dynamic LSPs using LDP. But if you are using traffic engineering RSVP, then go ahead and configure the LSPs using that. But again, the idea here is that for attachment circuits as well, is that attachment circuits can also be discovered using LLDP. So there is a flexibility that you can either define it through configuration, or you can go ahead and use LLDP for that. Moving along, we have some of the future work that I would like to quickly talk about. idea here is that, applications such as, backup, connectivity, disaster recovery, for generating large flows, right? So the idea here is that, we have some implementation proposal which talks about the off-network application and notification of large flows. And so if you have multiple LSPs between ingress and egress within the same network, and if you have determination of large flows, you can actually choose different types of LSPs in order to map those large flows onto those LSPs in order to really, again, a better quality of experience on that. And then, we have Ramki here from Brocade, who is leading this effort in IETF in the I2RS working group. So summary and key takeaways, that's my last slide on that. So just to give you this thing that this allows you to add new applications and services quickly and cost efficiently. You can create tenant network which spans multiple data centers using OpenStack. VMs may move to physical servers which reside in different data centers. We have now Neutron API extensions to provision layer 2 and layer 3 VPNs. And also you can use BGP auto discovery to discover remote PEs, especially in layer 2 VPN, which is highly dynamic and reduces the configuration. As well as, then orchestration and control can be carried out using central or distributed OpenStack client. So thank you so much.